This is chapter 8.2, written homework solutions from the textbook. This is problem number 14. So it starts off with giving us some situations about a simple random sample of size 1460 is obtained from a population of 1.5 million. And we have a population proportion with a specific characteristic of 0.42. Now in this problem, we don't have any specific situation. We're just kind of reviewing the idea of sampling distribution of a proportion. And so this proportion here is just with respect to some question that may have asked, and 42% of the sample or the population believes that. So part A, describe the sampling distribution of p hat. So if we do the sample from a population um, whose proportion is 0.42, meaning that they've answered some question at 42% rate, and then we start to sample from that population, there will be a distribution of those proportions if we sampled over and over again. And so some basic rules we need to review from the lecture is that the sampling distribution, again, how the proportion is if we continue to sample and get results, what does that distribution look like if we continue to sample with a given sample size n? We have these rules that need to be followed here. And again, we had talked about this in lecture that the shape of the sampling distribution will be normal, provided that n, the sample size, times p, the population proportion, times 1 minus p is greater than 10. So we need to check that. And then the other condition that we need to check is here, that the sample size needs to be less than 5% of the population. So let's do that quick just to ensure that we have that we're meeting these conditions here so that we can actually use the normal model to solve these problems. And so for this first problem here, let's go ahead and check for part A. Let's go ahead and check that. Let's do the 5% of the population. So 0.05 of the population, which is 1.5 million. There we go, one more. And when you take 5%, that equals 75,000. Our n in this case is 1460, so we have that number. And since 1460, not since, but the condition is met, since 1460 is less than 75,000, our first condition is met, which we had put what I had showed you. So this first condition is met based off of this here, coming back from your note sheets here, or the information here, or one of the conditions is met. When sampling for finite populations, this assumption must be verified. The sample size n is no more than 5%, which we've just verified for the sampling distribution. Let's go on to the next one. And so then the next thing that we're checking on this case here would be, so that's one condition that's met here. The next thing that we're looking at is that we need to do n times p times 1 minus p has to be, what we're looking for has to be greater than or equal to 10. And again, that was this condition, just to remind you from your notes. Right here, the shape of the sampling distribution is normal, provided that this is true there. And so let's go ahead and verify that. And so we put in the numbers. That would be 1460 times 0.42 times 0.58. That equals 355 approximately, and that's greater than or 10. So we have that other important condition. So the distribution is going to be normal. That allows us to go on to problem B, which is asking what is the probability of obtaining x equals 657 or more individuals with that characteristic. And so in this case here, what needs to happen is we want to go ahead and figure out what, so the x equals 657 or more. And so in this case, though, before I can do that, I need to, this is our proportion problem, so I need to convert this proportion. I need to calculate what p hat is. And so I need to calculate that from this number here. So that's 657 divided by 1460. We need to get that value, which just gives you 0.45. And so we need to convert this total numbers into a proportion because these are sampling distributions of a proportion. So we end up making that, turning that into proportion. And so now what we're really trying to find here, what's the probability that the proportion is greater than 0.45? So this is the problem we're actually doing here. So they gave us the numbers and we had to convert it to a proportion. Now how we answer that question, we need to use the normal calculator to do this, because we're talking about a normal model. We need to use the normal calculator to do this. But before we can do that, we need to convert this into a z-score, or not necessarily. What we need is the proportion mean and then the standard deviation. So we need that value before we can use the normal calculator. And so we need to go ahead and calculate those two values. What we know is this here. What we know is that the mean of the proportions, the mean of the sampling proportion is going to be equal to what we have over here, which is 0.42, which equal to p is 0.42. So we have that value. And then the other important value we have from class is we need the standard deviation of the proportion right there. And the formula we have for that is square root of p times 1 minus p all over n. And then so we go ahead and calculate that. And if we do that with the numbers, we need 0.42, 1 minus 0.42, which is 0.58, divided by 1460. And so what we get there is 0.013 approximately. And so now with those two numbers, 0.42, 0.013, 0.45, we can now go to StatCrunch and actually go ahead and calculate that value. Calculators, normal, and in this case the mean is 0.42, 0.013. So I was going to put 0.42 here, 0.013 here, and then we're looking for the probability that it is more than 0.45. And so our answer is we should get 0.01, what is that there? 0.011. So that would be our answer there. 0.01. We'd go with that one right there. 0.01 with it. So let's go ahead and put that in. Let's make sure we got all the numbers right. 0.45 greater than or equal to 0.42. Yeah. So this answer for part B is, in this case, the probability that p hat is greater than or equal to 0.45 is going to be equal to 0.011. 0.011. Okay, let's move on to part C. We can move a little faster now. Part C was a probability of obtaining x equals 584 or fewer, but that needs to be converted into what's the probability that the proportion is less than or equal to some proportion. So then we got to find the p hat, 584, because that's how many out of the population, out of our sample. 584 divided is 0.4, and so we're really looking at the proportion is less than or equal to 0.4. And so then we have the values already that we have here. We have our standard deviation for the mean, for the mean proportion, and then we have this standard deviation over here that we would use, and then we go ahead and use again stat crunch. P hat is less than 0.4. That will be the value we use, and in this case again we're going to use 0.42, 0.013 in our calculation. Normal calculator, stat calculator normal, and so 0.42, 0.013, and that it's less than 0.4. Let's double check we got everything right. Our 0.42, 0.0, there it is, and so then our answer should be less than 0.4, should be 0.01, 0.062 is what we should get, 0.062. So the answer is 0.062, the probability. Let's go ahead and move on to problem 18. Problem 18, credit cards. According to the creditcard.com, 29% of adults do not own a credit card. So in this case here, our P is 0.29. That's the population. And again, on this problem, there was no situation. We were just practicing kind of the distribution of a proportion, going through some of the kind of formalities of that. Here we actually have a context. Suppose a random sample of 500 adults n equals, so we do a sample from the population. Do you own a credit card? Describe the sampling distribution P hat, the proportion of adults who do not own a credit card. So in this case, we have to do the same thing here. Let's make sure that we're meeting these requirements here. So let's go ahead and do that. And so one of the first things here is we can check any of these first here. So let's do the n times p. N times p times 1 minus p has to be greater than or equal to 10. So we can go ahead and substitute those numbers in there. 500 times 0.29 times 1 minus 0.29, which is the complement. That is going to be equal to, so we need those answers there. That will be equal to, let me do that calculation real quick. That would be equal to, when we check that, that is going to be equal to about 102.95. That is greater than or equal to 10. And then in the next case, we know that n equals 500, so that's one check. N equals 500 is less than our population, and our population, again, we're assuming we're kind of asking kind of people in the country, so it is less than our overall population. Our overall population, I mean U.S. population, even a state's population. If this was just within a state, it's a smaller, so it's less than. And so then the next thing we would need to do some calculation of probabilities, we might as well do that now. We know that P is equal to, in this case, or the mean of the distribution of P hat, if we continue to sample, is going to be equal to P, which is equals to 0.29, which we had that already. And then the other important value, so we need this value, and then the other important value we need to do these calculations of probabilities is the standard deviation of the distribution of the proportions. If we continue to sample, the standard deviation is P times 1 minus P over N. And so in this case, the standard deviation would be equal to the square root of 0.29 times 1 minus 0.29. Sometimes it's easier just to do that calculation, which would be 0.71 over 500. And so then we get an answer of, we do that calculation of approximately 0.020. So now we have the important values that we're going to use with a normal calculator to answer our probability questions, 0.29 and 0.20. 0.020. And so let's go ahead and then answer part B. Part B is going to be, what is the probability that the random sample adults more than 30%, so that the proportion is more than 0.30. And so to answer that question, we go to StatCrunch. We go to StatCrunch. And that, let's make sure we're answering the question. More than 0.30, compute. And so we got 0.309. So our answer here is 0.309% of the samples would have a situation where more than 30% of the population will say they do not own a credit card. Part C, we're answering a similar question. It's a between one. What percent of the samples, if we did them, would have the samples say between 25 and 30% do not own a credit card. So we would go back to StatCrunch here, put a between, put a 0.25. The answer comes in already, and so you end up with a 0.669 as our answer for that one. 669. So about 66-67% of the samples would have adults saying that that between 25 and 30% of them will say that they do not own a credit card, and 66.9% of the samples, so around 66 or 67. Let's go ahead and answer part D. Would it be unusual? Get the key term there, unusual, for a random sample of 500 adults to result in 125 or fewer who do not own a credit card? So probability that X equals 125 or fewer. Now we got to, from the last problem, we need to convert that 125. We need to calculate a p-hat. 125 divided by 500. That turns out to be, our p-hat in this case turns out to be 20.25. And so what we're really looking for, what's the probability that the p-hat is less than or equal to 0.25? And we just go ahead and do that same calculation that we had, put a less than 0.25, do the standard, 0.25 less than, compute, and you get 0.023 here, 0.023. And since that's our answer there, we would then say for sure this result is unusual. And it's unusual because 0.023 is less than 0.025. So it would be unusual if you did a sample of 500 adults that 125 or fewer would not own a credit card. That would be unusual. That's it.